Hello everyone. Welcome to the week 4 CS15 NPTEL course, Blockchain and its Applications. For those who are joining for the first time, I'm Sai Venkatekrishnan, a PhD scholar from the Department of Computer Science and Engineering at IIT Madras. And the agenda of these live sessions is to, if you have any queries in the week's lecture or something, you can post it in the chat box, or you can unmute yourself and ask the query. Right. So, any questions? You can raise your hand and start speaking. Yes, Mahendra.
So, can you discuss question 1 and 4 in assignment 3?
Question 1 and 4. What?
Yeah, in assignment 3.
CS15. Assignment 3. Okay. Let me share the laptop screen. So that it becomes window. Windows Meet. Is the assignment question visible?
Yes.
Okay. So here assign question 1. This one, right?
Yes, yes.
Inspect and explore block 828070 using this link to solve the below question. What is the hash of the previous block for the Bitcoin? Okay, so they have given a block number and it is the hash. So they want to find out the previous block, hash of the previous block. Okay, so 828. Just move to the previous block. Right, so just you click on this arrow. So this is next block and this is previous block. So they gave 828070, and I just click on this left arrow, then it's view previous block it showed. And the first field over here, that's the hash. And if I just click on that, if I just enumerate it, it's the hash. And if I just look at the options, only one is correct, 246, right? 246 EFF8, this one over here. Let me just.
Okay.
It
But
en-
it will not be visible on the same block, is it? The previous block's hash, it will not be visible on 070. That we
uh,
can't see.
it will be visible to distance. So it might be visible also. Wait, so these are all the transaction details and environment and to learn the tweet reward consisted, okay, hash, okay, capacity, BTC value, input value, output value, transactions, witness, okay, input, output fees, depth, size, Merkle group, difficulty, nonce, bits, minted reward, mined on, height, 828069. No, so um, see, it will be visible on the block header, but this is finally like a UI, right? So this blockchain.com is not the actual blockchain itself. It just looks at the blockchain that is available. It will have say a node connected to the Bitcoin network, And what it will do is it will lay out all this information in a manner which is understandable to the user. So the previous block pointer would be present within the block header, but instead of showing it within these details, it is showing it over here, Bitcoin block, and giving you this left arrow and right arrow to view the previous or the next block. So it's just UI thing only. So it might, so for example, I can cut off all these extra information. So I can like do it like advanced information or just simple summary showing just the hash BTC value earned transaction, that's it. All this fee range everything also I can just remove off. So it's
Okay.
up to the website UI designer. So they
Okay.
have taken this approach. So say if you go to some other website like a raw website or something, this the actual header itself you can see. So yeah.
Okay. I just want to know, the hash pointer will point to the hash of the previous block.
The hash pointer.
In the normal blockchain, the hash
Okay.
pointer will point to the which
The previous it so it would be like the previous block, the hash of the previous block would be included in the uh, along with the transaction data which is to be hashed. So per se, like the term pointer, as in it don't point to a specific memory address like that. So your C pointers,
Okay.
it's not like that. It's
Okay.
just that say like block one is there. Say hash the hash of block. So in order to solve that puzzle, right, you should be going through all the possible nonce values to find out whether it's lesser than that difficulty or something like that, more than the target. That condition is there, right? Number of zeros and all those things to solve
Yeah.
the puzzle.
Yeah.
So for that, all the data, the transaction data, everything will be hashed, and along with it, even the previous block hash should be present in the block 2 data. So that's the reason why if I have to change an old block in the blockchain, I have to sort of solve the puzzle for all the consecutive blocks, which is time consuming. So that's the security of the blockchain because it includes the previous block's hash. So that they call it as hash pointer. It's pointing to the previous block's hash. That's it. So
Okay. Okay. Fine. So the fourth one, you can
yeah,
just
fourth
have a look.
one. Okay. Fourth one. Okay. So I checked it, the question. So difficulty is usually represented as 4 bytes only. Here they have given it as 6 bytes. But that's not an issue. Like so, the correct answer is A. So even if it's like 4 bytes difficulty or something, right? The in the um, in the slides, they what they have shown is the first, the most significant byte, right? That will be the index, that y value. The remaining part will be this x value. So in the slides, they have given like a 4 byte value and taken that first byte and the remaining 3 bytes as x, right?
Okay. Okay.
Here
Yeah.
they have just given 6 byte value. So if the 6 byte difficulty, so they have just assumed it to be 6 bytes. That's it. So though Bitcoin actually has 4 bytes only, so it's nothing wrong in having 6 bytes also. It's just like they have assumed it in this question. So you can mention like 4 bytes is the correct thing or something, but they have not specified it's Bitcoin or something else, right? So based on the explanation, like you could have gone for that for the option A because it sort of matches with the explanation, right? The first byte is for Y and the remaining bytes is for X. And that is precisely what is option A basically. So you could have selected that option to be on the safe side.
Okay. Okay.
Hello,
Fine.
sir.
Hello? Yeah, let me finish Mahendra's questions and I'll come to you.
I had one more question, but maybe we can take that for later because that relates to Ethereum.
Okay, sure, okay. Yeah. So anyone else? Any other question? Okay, Shriman has asked in the chat box, how is the seed node identified for joining the blockchain network? Which is the okay, the seed node, a term I didn't understand. Where did you look at this? Like, uh, what's a seed node? Shriman, are you there?
So the first node of the blockchain, sir.
The first node of the blockchain. Okay. So, okay, first block is okay. So it's like so when you join the blockchain network, right? So how is this? So Genesis block is the first block that gets added to the blockchain. So that is like sort of we should trust that's the correct block. Similarly, like when you so the blockchain, this for example, this Bitcoin means there will be like a repository or something from where you will download uh, the software and all those things. Like you won't be coding it yourself, you will be downloading. So as part of that download thing itself, um, there will be some hard coded values, as in like it will try to identify which are the peer nodes that is closely connected to you, similar to how your torrent websites work, right? So it will just sort of provide you with some peer node values, network nodes that is nearby to you. Like say, if you are in India, like you might get what's that term, Singapore or the nearby countries, Thailand or something. So nodes in those countries, so that communication delay will be less. So it's part of the software like that. Like some network nodes will be sort of like there will be like some maintainer nodes or something usually. So Bitcoin is basically like an open source community, right? And if they want to upgrade the code in Bitcoin or do something, like all of them should sort of chat over mail or something like that, or send out proposals and then upgrade the software and all those things. So that the upgradation itself is a complicated process on these Bitcoin, especially Bitcoin. So what usually they do is but some say for example if you take a company you will have like a CEO and all those things. Similarly in Bitcoin, like few key people would be like well known in that community, so everyone would sort of trust them and like they'll be like flag bearers. So they will be maintaining some nodes, or some nodes would be very common. So for example, this Google DNS server, if you want to, instead of connecting to your internet broadband's domain name service, you can connect to Google's DNS server 8.8.8.8, I guess, or something like that. So similarly, some well-known nodes should be there. You can first connect with them and later you can switch to some other nodes based on the connectivity speed and proximity and all those things. So it will be sort of hard coded mostly when you download that software itself. So the term that you used over here, Shriman, like there is no specific server to connect. Basically, every node is server on its own. So a node can either become a client or a server. It can be in both the cases. So it can serve other nodes request as well as it can ask the other nodes for request. So that's the distributed model we are looking at Bitcoins. Okay. So Abhijit Ardalkar has asked doubt regarding mining. What if the miner guesses the nonce correctly, but we taught the proper order of transactions in the block? So what do you mean by proper order of transactions, Abhijit? Is it like are the transactions valid, or is it like the transactions are invalid? So what do you mean by?
Yeah, actually,
Yeah,
can you hear me?
yeah, I can hear you.
Yeah, I wanted to know about the puzzle thing. The puzzle is related to only guessing the nonce number, right?
Right.
Or something else.
Yeah.
Yeah, if we get the nonce correct,
Okay.
but the transactions which are appended in the new transactions which are arrived in the network, if that user doesn't arrange those transactions in proper order, then what happens?
So I didn't get it. So can just repeat it. Sorry. I'll just write it
Yeah,
down.
the new coming transactions, the user need to arrange those transactions in proper order, right? With
The
their right timestamp, etc.
uh, user as in, so say Akshay is there. He wants to send some bitcoins to Bharat, say 10 bitcoins, and this is transaction one.
Okay.
Now, this transaction, so here, Akshay is the user you're telling, or
Yeah, there might be multiple transactions happening at that moment.
okay, multiple transactions, okay,
Huh. Then and multiple miners will
okay,
be there to mine those new transactions, right? They will be creating new blocks.
okay,
So before getting that new block accepted into the network,
okay,
all miners will be trying to first create those blocks,
okay,
right? And they need to arrange those new transactions in proper order.
right, proper
Yeah,
order,
but
okay,
yeah, but what if miner doesn't arrange those transactions in proper order, but he guesses that uh, what that number nonce correctly.
so so when you tell proper order, what do you mean by proper order?
I mean, he can add malicious transactions also there, but he
So that
guesses the nonce correct.
so so it is not proper order, that is invalid transaction itself, right?
Yeah, yeah, yeah.
So
Like that.
when you tell ordering means, say like Akshay is sending to Bharat 10 bitcoins, and this 10 bitcoins Bharat is sending to some other guy, Chandra, the same 10 bitcoins, and say this is transaction 2,
Huh.
right? So in this case, when you mention order, it is like either transaction 1 and 2 can be both in the same block, or in first block transaction 1 and second block transaction 2. This is proper order. It cannot be the case that first in block transaction 2 is there and then transaction 1 is there, because without transaction 1 transaction 2 is invalid. So this is wrong order. So is this your doubt?
Yeah, but the multiple miners will be trying to create that block,
Right. So
right? They will
your
be trying to
question
add
is,
that block.
if say your question is, if they get the nonce correct but improper invalid transactions are there in that block, will that block be
Yeah, yeah,
accepted or not?
yeah, yeah,
No, it
correct.
won't be accepted. So the puzzle is just ticket to ask others to check your block. That's it.
Okay,
So puzzle is the first thing. Once the puzzle is over, then everyone will check that block. Otherwise, they won't look at your block also without solving that puzzle.
okay,
So puzzle is like a basic condition, because otherwise without a puzzle what will happen? Uh, the miners, they will just take one transaction, place it in the block and send it out, because every block you will get a reward, right? So without a puzzle, they'll just blindly keep on sending. They themselves will just send themselves like one Bitcoin, like point. So Bitcoin is like not one Bitcoin, right? They have it in satoshis, like one Bitcoin is 10 power 8 Satoshi, similar to rupee and paise, right? So they can just send out like 10 Satoshis or something like that to themselves each transaction, and they can just send out each block if a puzzle is not there. Then each time they will be getting a mining reward. So to stop all these things and to decongest the network, only this puzzle and everything is there, and also to strengthen the security.
okay. Okay, sir.
So,
Thank you.
so just a follow-up to what Abhijit was asking.
Yeah.
If a miner solves a puzzle, is there any minimum number of transactions which he has to include in the block, or he can just do even one or two and just pass on the block?
There is no such minimum number of transactions. It can be empty also. So there is some logic for these empty blocks in Bitcoin. I don't recall it correctly.
Okay. No, I'm saying in consensus, there is no validation on the minimum number of transactions which you need to have in a block. Otherwise, it will not be
No,
added.
so there is a consensus for the maximum number of transactions because the block size which, to verify and all that thing. So once you get a block, so basically when you send out a block, it will be like a block header followed by all the transactions list, right? And your block header will contain details of the hash of the block and then who is the miner and all those things. And once this is done, the transaction list will be there, or transaction 1 to so many transactions. So when the miner sends out the block for acceptance, all the nodes, the validating nodes will see the block header and check whether the hash of all these transactions along with the nonce everything is less than that, it's having that proper target condition or not. So this entire thing would be sending out. The miner will be sending out on the network. So there can be a denial of service attack if they send out like a 1 GB block or 1 TB block, because it will be like, so the network will go down, right? If they send out these huge blocks. So there is a limit, hard limit on 4 MB or 8 MB block, one of these two. So it was increased from 1 to 4 or 4 to 8, something like that. So there is a limit on the maximum size of the block, but there is no limit. There is no like minimum limit.
Okay.
There's an upper bound. That's it. And there are empty blocks also, because like so sometimes say the miner is there, but he doesn't get any transactions or something. During that say a minute or so, there are no transactions. So what will the miner do? Like he has there is this mining farms, right? They will have like multiple systems running, looking out for transactions and trying to solve the puzzle. And if say like for some period of time there is no transactions coming in or something, what they can just do is they can just mine an empty block without any transactions itself. And as if they are able to get solve the puzzle for that block, they'll be able to add that block to the blockchain, and that won't be discarded because it just increases your blockchain length and also sort of strengthens your blockchain, right? Because now your blockchain is longer, and it sort of now adds to the security of the blockchain. That's it. So it's like a waste of space. The miner is the only one getting the rewards, but it don't do something bad to the network. It's not like a spam or something.
Okay.
It just like adds greater security, because the strength of the blockchain is like for example the term blockchain, um, the blockchain length is sort of proportional to the strength. The strength of the blockchain is proportional to the height of the blockchain, especially in Bitcoin type of the blockchain examples, right? So the more the number of blocks, say for example you have block 1, and on top of that if you have 10 blocks it is secure, and it's more secure if you have 20 blocks on top of that. Because if I have to change the first block in the first case, like say you have B1 and followed by that 10 blocks compared to B1 followed by 20 blocks. If I have to change B1, say I have to spend 5 hours trying to solve, if I change this block B1, I have to recompute the hash, right, for all the consecutive blocks, recompute the hash and solve the puzzle. So for 10 blocks, say I can do it in 5 hours, but for 20 blocks, it will take double the time at least. So it will be like 10 hours. So if they add empty blocks in between, it will just increase the block height, and also it increases the time or the commitment for the attacker to change an older block. It makes it difficult. So it sort of increases the security of the Bitcoin only, even though it looks like spam message. So is that clear?
Yes, yes.
Okay, good. Any other questions? Anyone?
So can I ask this thing related to Ethereum, if it's okay?
Yeah, sure. I'll try to answer it.
Yeah. So in Ethereum, you can have your own network apart from the main Ethereum network. So you can have your own like private networks also.
Wait. Can you repeat it? Sorry.
I'm saying apart from the main Ethereum network, and you can form your own private network also. That's what
Okay.
I. So in that case, how will the consensus be arrived? Because you can't have mining or POW in case of a private network which is formed.
Okay. Okay. So a private network. So once you tell a private network, right, the nodes participating in that network would be limited, restricted. So if you take the example of Bitcoin, why did it become a revolution? Is like it's fully open to everyone. Anyone can, with a laptop or something, they can join the network and participate in the Bitcoin computing, validating the transactions, anything they can do. They can even try to attack the Bitcoin. Nothing stops them from doing it. It's just that they won't have that much computational power. That's it. Once you take a network private, so for example, there is this hyperledger fabric. So you'll be learning about that in the later weeks of this course. So those are all sort of mainly used for enterprise blockchain. So you would have you would have read some news like the blockchain for this like supplier items, or like the supply chain blockchain and those things.
Yes.
So those things will be sort of like permissioned blockchains. Like so, you with just a laptop or something, you won't get permission to join that network of nodes in the first place. There will be like a username, password, and someone should first of all invite you to join that blockchain. And there the purpose of blockchain is just to since like the um, what's that, since it's like a private network, right, you know what all nodes are present in that blockchain. So uh, uh, the problem with the Bitcoin, the difficulty with Bitcoin is, why did they have to select this form of puzzle solving as a common consensus, right? Why can't they just go with like a simple consensus idea where many nodes are there, and they can just ask the nodes yes or no, and if majority of them tell yes, that block is accepted. If the majority tell no, they can just reject that block, right? But why is that not possible in Bitcoin is it's a public network, and you don't know what nodes are there at all in the first place. The number of nodes would be fluctuating. So at one time it will be like 1,000 nodes in the daytime, in the night it will be like 100 nodes only. So um, so that is the difficulty with Bitcoin. So for that, they came up with this mining puzzle and all those things to sort of strengthen the security of the Bitcoin. But once if you take the network private, you won't you will know what all nodes are present. You will know the number of nodes that are present, that have joined the network, because you will be inviting the nodes, right? From the public or something, just like that they cannot join the network. Everything is monitored. There'll be like an admin or someone, like say like three companies together are forming a private network, say for that supply chain issue, blockchain and supply chain, right? So all the companies, the stakeholders together, they'll be maintaining this blockchain network. They will be validating each other's nodes to join the network, and among those nodes it is easy to reach consensus just by this simple method of saying yes or no. So there they won't require this proof of work or something. It's just that the majority should tell yes or majority should tell no, that's it. And the assumption in that network, so in Bitcoin we had the assumption that 51% of the hash mining power should be honest. In that private network, it will be the assumption that 51% of the nodes, or two-thirds of the nodes should be honest. That's it. Honest as in it should not be malicious. So for example, like there'll be like n nodes, like say 6 nodes or something. So n1, n2, n3, n4, n5, n6, and it's a private network, so these are the only nodes participating, let's assume. So in that case, say n1 proposes a new block, means say block b1, it sends out, hey, I'm proposing a new block to all the other nodes. So since n1 will know it's a private network, it can like broadcast the nodes. There won't be like multi-hopping, as in a Bitcoin setting, you will just know like the nearby, the neighboring 4 nodes or 5 nodes. You won't know all the nodes present in the Bitcoin network, because some might be offline, some might be online, some might like some might be newly joined, and all those uh, uh, stuff. So in a private network, you know for a fact that these are all the only nodes present in that private network. So you can just broadcast it to all the nodes. And what the other nodes will tell is, they will sort of look at the block, they might validate, and they might arrive at a conclusion, replying, say n2 will reply yes, n4 will reply yes. So this reply also will be a broadcast. So basically, n2 will send out a message, reply from n2 yes, and it will send out to all the other nodes what is n2's reply to n1's blocks. So it will be n2 is like it. So similarly, n4 will send out whether it's an yes or no to all the other nodes for this block b1. So like that, all the other nodes will be sending out, broadcasting the replies to all the other nodes. And finally, what will happen is, like say for example, if we look at n5, node n5, it would have received a reply from node 2s, node 3 will be no, node 4 would be yes, and node 6, sorry, and say node 6 is um, is node 6 is no. So now let us keep this, let us take another node also for clarity. So let there be another node 7, node 7 also. So in that case, let us take node 7 tells no. So in that case, majority is no. So block B1 would be rejected. Okay. So this is N5 will see. Now let's say like if the N7 node is malicious. So if this is a dishonest node. Now what this node 7 will do is, it will send no to node 5, and it will send yes to node 3. So node 3 will get the same set of values, but node 7 it will get as yes. So for node 3 it will be majority as yes. And what it will do is, it will accept the block, whereas in node 5 it will reject this block. So a dishonest node will send this yes or no messages randomly or something, like it will have a plan and it will send yes or no in a different way. And what finally happens is, there will be like a partition in your network, in the private network. some set of nodes, say node 3 and say node 3, node 2 and node 4 would have accepted the block. Node 5, so node 5 and node 4 would have rejected that block. But in a proper consensus algorithm, it should be the case that the block should either be accepted by everyone or it should be rejected by everyone. So so that's why like there should be um, assumption that 2/3 or something like that, some specific um, threshold should be there uh, for the number of honest nodes. So that your majority, when you take that decision, it can you can safely assume once if the majority is yes, it is to be yes only. Uh, even the dishonest node, if it sends out conflicting messages, it don't affect the majority result. So in this case, proof of work all it don't matter because you know all the nodes and you just want an yes or no. That's it. So that's why these permission blockchains are pretty fast. These private networks, they don't have to. Um, uh, so in Bitcoin, it is usually like one block per 10 minutes, something like that, right? The time taken.
Yes.
Yeah, so whereas in permission networks, it's sort of simple. It will just take some time for this broadcast and everything, depending on the network number of nodes in that private network. But apart from that, it's sort of super fast. And yeah, so usually like whether you want so the term blockchain is supposed to be a fully public permissionless blockchain, like that. But these sort of this hyperledger fabric, these private networks and those things, these are all sort of like not the proper blockchain. They take the concept of a distributed system with blockchain and everything, and they just sort of try to bring transparency among the set of users, the private users. That's it.
Okay. Fine. Thank you, sir.
Okay, sure. So Sriman has asked a long question. Let me try to answer. It appears that a given minor node can add a new block to its local blockchain once it solves, even without consulting. It then broadcasts the block to the remaining nodes, but this block need not be the final because different minor nodes may add different blocks. Okay, minor M2 might create block. Okay, so at level L, two miners added two different blocks, conflicting blocks, both valid. At what point a final block is selected? When does the miner come to know if its block was accepted by at least 50% of its peers? So little bit about the term. Okay, so Sriman, you have asked a very good question. This is what is called as forks in the blockchain. Okay, so forks in Bitcoin. Okay, so bear with me if I use the term blockchain in this particular lecture. It's like usually Bitcoin only. That's what you have been learning. So when we take say block, say we have node 1, node 2, node 3, node 4, node 5 and node 6. Assume all are minors, so all are minors anyway. So and minor node 1, uh, block 1 and this is block 2. Okay, so say assume this is block 10 and this is block 10. So basically this is block 10 and this is block 10 prime, because n1 and n2 both will be pointing to the previous block 9 only, right, and both are valid. So we say suppose both finished at the same time, not same time also. Assume like n1 finished mining this block 10 at say 6 p.m. N2 finished at say 6:30, right? It can be different times also, no need to be same time. But n1 is not in any way connected to n2. It doesn't know n2 is present. It just knows n4 and it knows n5, whereas n2 knows n3 and n6. And say some other node like n100 knows both n1 and n2, but the time at which node 100 will receive node 1's or node 2's block, say it receives node 1's at 7 p.m. and node 2's block at say 7:10 p.m., something like that. So there is no way that node 2 would have come to know node 1 had already mined a block B10 from node 100, because 6:30, like node 100 itself would have learned on at 7 p.m. only that node 1 had mined a new block 10, whereas node 2 would have already mined a block B10 prime by that time. So now what usually will happen is this adding of blocks is a localized decision. It won't consult with the other nodes whether to add this block or not after it has checked its validity and whether it has whether the puzzle is solved. So if the puzzle is solved and all the rules for that block, the validity rules are all there, validity check is over, the node will just add that block. Okay, so the node will just add a block, and it's just a case. What will happen is for node 2 and for node 4 and 5. So node 4 and 5, um, node 4, 5 and node
Sir,
1.
can you explain once again, sir?
Which part?
Sir, I can't understand that from the 6:30 you have announced, no, sir.
Okay, so like I'm just giving timestamps. So, so say assume like node 1 mined the block B10 at 6 p.m. Node 2 mined it at same like a different block but at the same height, as in it is pointing to B9. Both are point, previous block is B9 only. Okay, and assume it is 6:30 p.m. Different time basically, so it can be any two different times, and node 1 is connected to node 4 and node 5, and node 2 is connected to node 3 and node 6. Okay, so this is the assumption, and at the time when node 2 is mining the block, you might think that okay, node 1 mined this block at 6 p.m. Why didn't node 2 get to know the block? It might be the case of some network failure or something like that, where node 2 did not receive this B10 block from node 1. So it assumed no one has mined a new block on top of B9. So it mined its own block B10 prime. So till here you understood, Balaram?
Yes, sir. Thank you, sir.
Okay. So now what will happen is all this block acceptance or reject will be localized decisions. As in node 4 and node 5, when it receives block 10 from node 1, it will check the hash puzzle whether it's solved, and it will check the validity. And once it is done, what it will do is on top of B9, it will add B10. Whereas node 2, node 3 and node 6, it will check B10 prime, it's a valid block. Assume that these nodes also haven't received B10. So in that case, what it will do on top of B9, it will also add B10 prime. Now both these are valid. Okay, so what happens is basically from B1, block B1, B2, B3, like that up till block 9 will be there, and basically that's a fork in the blockchain. Okay, so this fork, what happens is a fork basically is two different blockchains usually now exist. So this is one, this is two, and the nodes supporting this are N1 4 5 nodes 1 4 5, and this is nodes 2 3 6. Now you might ask which block is then correct, and here's what block Bitcoin usually tells is the longest chain, or the chain with the most hash power. So most of the case just stick with longest chain itself, most uh, hash power is the correct one. So what usually happens is these forks automatically resolve after some time. So what I tell by resolve is, say these set of nodes. So nodes 145 will be following this first one, and nodes 236 will be following this second block. So till here you understood? Any doubts?
No, sir.
Sorry?
No doubt, sir.
Okay. So uh, now what I mean by the fork will get resolved automatically is, there will be like difference in computation power, or different transaction or something like that. So what will happen is, say nodes 145 are together, like they are able to solve the puzzles for more blocks. Say they are solving the puzzles for 5 blocks in 1 hour also. Okay, and say nodes 236 are solving only 2 blocks per hour. Okay, now what will happen is, after uh, an hour also, what would have happened is, on top of block B10, nodes 145 would have added 5 more blocks, that is up to B15, whereas nodes 236 would have just added up to B 12 prime, B11 prime, B12 prime, whereas nodes 145 would have added up to blocks 15. Okay, now let's assume, like for 1 hour, whatever blocks node 145 has added to the blockchain, all these blocks, right, block 10 to block 15, nodes 236 didn't know, some due to some network failure or something. Let's assume there was a network failure and the nodes were disconnected from each other. These set of nodes, nodes 145, were disconnected from nodes 236. Now say after 1 hour, connection is restored among these nodes. Now what will happen? There will be like a synchronization operation where nodes 145 will tell, hey, these are the latest mined blocks I have mined, and they will send it. And nodes 236 will receive those information, and what they will see is, in their blockchain, the local version, they are just having till block 12 prime, that is till height 12, whereas in the new nodes that they are receiving the blocks from, the new blocks, it is up to 15. So which is a longer chain? 15 is a longer chain. So what they should do is, they should all delete these blocks, as in they just become orphan blocks. And what happens is, all the transactions in this block, right, say for example, 100 transactions in there present in these 3 blocks, means all these transactions will be are not confirmed yet, as in they are not yet part of the Bitcoin. So till that during that 1 hour, they are present in these 3 blocks. But once the nodes node 236 found out that another fork is there, like fork 1, we call it as fork 1, right? So another fork is there, which is a longer fork. Then what happens is, all these nodes switch to that fork and start mining on it. So they will start mining on top of this block 15. Now you might ask, what will happen to these 100 transactions present in these 3 blocks? Now what the miner nodes will do, nodes 236, is they will take those transactions again, those 100 transactions, and try to mine it on top of block 15. Now, uh, now they can add like block 16 or something. They can propose new blocks. So basically, the Bitcoin is sort of, the definition for Bitcoin is, it's the longest chain among all the forks. So when you look at your blockchain, the Bitcoin blockchain fully, it will be like something like, there will be too many forks happening, something like 3 or something like that. Now finally, whatever is your longest chain among all the forks, this one over here. So this will be your valid Bitcoin. The other is all like it's not invalid. It don't. It's not proper to be on those chains. So they usually call this as the main chain. And you might ask what will happen to all these other forks which is not the longest chain. Those forks either might get they are just like orphan blocks, as in they don't have any meaning. It's just that they sort of be there, that's it. You can discard those forks also, or what will happen, like they will sort of that fork will become permanent. So what would happen, like in some cases, is um, what might happen is, say like node 236, they got to know that till block 15 there was fork 1 was present by was built by these nodes 145. It might be the case that these nodes 236 will be adamant and they won't switch to that new longest chain. They will continue working on that new uh, on their fork itself, on fork 2. And what will happen is, all the nodes now operating on that fork 2 will form a new cryptocurrency, say Bitcoin 2 or something. So in the Bitcoin news or something, like long back, there is like Bitcoin Gold, Bitcoin Cash, the original Bitcoin, like that. Basically, what all these three denote is the Bitcoin blockchain, but each denotes a different chain on that blockchain, on the entire Bitcoin blockchain. Say like some nodes might not agree with the other nodes and they might come out and follow a different fork. So it's like forming a new nation and telling like, I don't want your currency, I minting my own currency, right? So you can as well, like say myself and Mahendra, we both can just form a new fork on the Bitcoin and tell it's like yeah, NPTEL cryptocurrency also. It has full valid significance and meaning to it. But the only issue is no one will be buying those cryptocurrencies except myself and Mahendra. So it don't have any value and it will be a huge loss for both of us. So that's the concept with these forks and all those things. So is this clear, Shriman? And you have asked a question, at what point is a final block selected? When does it when does the miner know if its block was accepted? So um, uh, uh, when is the final block selected? So the term we use for that is called blockchain finality, block finality. So what we so when will a block when is a block finalized, or when can we be sure that a block won't be discarded as part of a fork? Is that say block 10? So say for example I'm sending out a transaction that is say T9, and say that is part of block B10, means I should not immediately say once if I just see block B10 at the head of the blockchain, I should not believe that this T9 is confirmed. Instead, what I should do is I should wait for other blocks to get added on top of this block. So the significance behind this is, it's like getting to know that the other nodes accepted this block and are mining on top of the block B10. So that's the only way you get to know whether your block is accepted or not. And usually, like the threshold value is, if at least 6 blocks get mined on top of your block in which your transaction is included. So B11 means B14, B15, B16. So if 6 blocks have been mined, then there will be like it will usually be like 90% or more than 90% confirmed, because it would have been like 1 hour, and by that time, even if there is any network disconnection or something like that, the nodes were not able to communicate with the other nodes and a fork was there, within 1 hour it will mostly be resolved, or at least in 2 hours or something. And finally what will happen is um, your beaten block would eventually be part of that longest chain only. So in that case, it is confirmed. So see, this blockchain finality is a tricky issue, because you might think I can wait for more number of blocks, as in I can wait for 20 blocks and then accept it. Okay, so for example, if B10 is there, means I can wait till block 30 is present on top of it, 20 blocks are there, and then I am sure that this transaction is 100% confirmed. But this logic is wrong, because say a minor node is there which has enormous computational power. What they can do is they can mine empty blocks, or they can mine new blocks of their own with just one transaction. They can start from block 9, not from block 10. They can start from block 9, and they can form a new chain itself up till block 40 also. Now what will happen? This is the longest chain and this will be discarded. So even after 20 blocks, your block 10 is discarded. So it's not yet confirmed. Okay, so there is this uh, thing in Bitcoin is your transactions are not confirmed during its lifetime. That's the hard truth, because the longest chain can change anytime. That's where the assumption of 51% computing power should be honest comes into picture. So this example I showed, where like a miner with enormous computational power will try to outrun this longest chain over here by adding more blocks, adding 30 blocks or more than that, and forming a new longest chain, right? So this won't happen. Uh, this doesn't happen. That's the assumption they follow, because if such a mining power is there, then it should be more than it should be like majority of the hash power. And as your blockchain height increases, as you add more number of blocks on top of block 10, the hash power or the mining computational power to change the longest chain, to remove that block and form a new longest chain, will become more and more difficult, and that will be in contradiction to the assumption that we have like 51% of the computational power to be honest. So is this clear, Shriman? So because of the issues in this blockchain finality, and the way in which this longest chains usually work, because longest chain, if someone has more power, the longest chain will can change also if they start to work on a different fork. So if 51% is honest, then it won't usually be the case that the longest chain would constantly be switching. There will be like minor forks happening for 5 or 6 blocks, but it will eventually be resolved. So is this clear, Shriman? Anyone else any doubts regarding this?
Yeah, so yeah, related question was that. So if I am doing a transaction, is there any validation which tells me that I can do this transaction now, that it has reached some finality? Because when will I do the transaction in that case?
No,
Suppose,
so
supposing
okay,
supposing T9, I just elaborate. Supposing T9, I was receiving some bitcoins, and T10, I want to give some bitcoins to it. So
right.
when can I be allowed? Is there any validation on that which will prevent me or which will allow me?
So T9, so you can either send T9 or T10 at the same time itself. So if you have the transaction, T9 is the one you are receiving, right? So if you have the transaction in hand, or like say someone is there, someone is sending it to you, and they like called you and told, hey, I've submitted the transaction to the miner, right? You can immediately submit transaction 10 also to the same miner or to a different miner or something. Now, what happens usually is uh, it will sort of, it's up to the miner to say like uh, say say both the transactions are to the same miner. That's not an issue, right? That's like a trivial case. But say T9 goes to miner 1 and T10 goes to miner 2. Miner 2 will check whether T10's input is present in the UTXO, because the output should be um, unspent output, right? But what
Yeah.
happens is T9's UTXO is still not created in the first place. So probably miner 2 will think that T10 is sort of like a future transaction, and there is a term in Bitcoin which is called as mempool. So mempool is basically like all waiting list transactions or unconfirmed transactions. So from these transactions, the miner can pick any transaction and add it in the block and try to solve the puzzle. So T10 will be present in the mempool, and say the miner will be constantly monitoring the new blocks being added to check whether some of the transactions that he was trying out in the puzzle are already added or not. Then he will remove those transactions, place new transactions, and try to solve the puzzle. So at that time, he might notice T9 is present and it has created a UTXO, and those are pointing to T10 basically. So at that time, he will add it. So is this
Okay.
clear?
Yeah. So, okay, if I am say I have received T9 and I am not sending it to anyone. I want to encash it, or I want to say go to a store which accepts this and want to buy something.
Right.
So when will I am certain, because I am not. This is never reaching a finality, as you said. There is no
Right.
100% finality in this case.
Right. So
So
it will be like 99.9%. That's it. And
so it,
they have this chart where like after 6 blocks, the percentage of finality is 90 to 95 like that. So that's why they aim at 6 blocks, 1 hour. So after say you go to a shop or something, you want to buy a coffee, it will take 1 hour for the tea shop guy to confirm and give you a cup of coffee. So
okay, but he's still not sure whether that is going to hold true or not. It's 90% sure in that case also.
it's 90%. So it depends. So like that's like a small value item. So the loss won't be that much. So even if it's not confirmed, it might be confirmed in the future too. Because that will be part of the mempool, and that miner can add the transaction in a future block. He can hope, right? But
Okay.
say this is like a high value item, like you are buying a Lamborghini car or something, right? In that case, until they get like at least 20 blocks or like even like 100 blocks or something, till then they won't release the car. So the value of the item and all these things will also might also play a role in this finality and all these things. So that's one reason why Bitcoin is not widely adopted. So the major use case of Bitcoin is one is in this cross-border transactions. Say, if you want to send money from here to US, there'll be like many entities present in between. And even if you just want to send 10,000 rupees, they will take a commission of 1,000 or something like that, and it will take like 3 or 4 days to confirm, because in between there'll be like multiple banks and those institutions and all these things to convert from rupee to dollar and all those things. Whereas the Bitcoin, you can convert your rupees to Bitcoin and send via the Bitcoin uh, network itself as like Bitcoins, and then over there they can convert it back to US dollars. So this entire thing, even if it's like not 1 hour, you can wait till a day or something, which is lesser than the 3 day wait time, right?
Okay. No, I'm just saying, if even if my intention is honest, I'm sending a cross border, say, to a university,
Right,
and because of my, not my fault, I mean, because of, as you said, there is a whole way, the way in which the consensus works,
right.
the person is not able to get those things, and because of no fault of mine, I'm saying, so that those situations could arise in this case, right?
Right. So once you have sent out a transaction, right, there is no way of um, um, repealing that transaction unless you send out a new transaction. So if you're honest, so what usually happens is, uh, so say like you're sending some bitcoins to the university, one, and you will be using some UTXOs, right? If you are honest, you won't be sending out another transaction to another university pointing to the same UTXOs.
Yeah.
So in that case, there's only one transaction pointing to that specific UTXOs. So eventually it will be added to blockchain. uh, it might be the case that your fee that you want to provide, that you pay the miner, might be too low, and none of the miners would be willing to process your transaction. In that case, what you can do is you can resend a new transaction with a higher gas fee or something, or if you know a miner personally, you can submit the transaction to that specific miner with a higher fee or something pointing to the same UTXOs. Now you might wonder, like, the two transactions are there and will I be charged double? No, only one of these transactions will be present in the blockchain and the other will be automatically discarded because that UTXOs would be spent with respect to one only.
So the fees is not standard. I mean, I can decide my own fee, is it?
Absolutely, you can decide your own fee. You can pay no fees at all. You can pay one satoshi. You can pay how much ever. So based on how much time you want to wait for your transaction to be added in the blockchain, the fees you can decide and send it.
Okay.
Because finally, like, there is no compulsion for the miner to accept your transaction in that block while solving the puzzle. They can just mine empty blocks also. So in that case, what is the incentive he is getting apart from the mining reward? So the Bitcoin rewards that he is getting is from mining blocks. He can mine empty blocks also, right? Why should he include your transaction?
Yeah.
Ranakam. So in that case, the only extra incentive you'll be getting is this transaction fees. And that transaction fee, if you want your transaction to be processed first, priority given, then you have to pay a higher fees. So the miner, what they will do is they will look at the high fees transaction and try to include those in the blockchain first, because if it succeeds, if they are able to solve the puzzle, then those high transaction fee um, all those transactions, that they'll be able to get more profit. That's a business for them basically.
Okay.
And so let so Ashok has asked a term question in the chat box. Explain a little about the term attacker gained control of more than 51% of the computing power. So this is exactly this longest chain that we discussed, right? So if the attacker gained more majority of the power, then it will be the case. Then he can rewrite the entire blockchain, or he can sort of form a new longest chain and confuse the others, saying this is the valid longest chain and not the others that they have been mining on. So it basically like renders all the other miners whatever computational power they had invested. It's all a waste, complete waste at the end. Um, M. Vagishwar has asked, can we apply blockchain technology rather than cryptocurrency like GPay? I didn't understand this question, Vagishwar. You want to apply a cryptocurrency like thing to GPay, is it?
Sir, blockchain technology is for cryptocurrencies only, or what?
No,
We
so
can
you
apply in GPay, sir.
no, so you have this new kid in the block, right? CBDCs. So central banks digital currency.
Yes, sir.
So these are sort of government issued and these run on the blockchain. But the blockchain would be controlled by the government, and it's basically instead of so when you take the example of debit and credit cards and all those stuff, right? Even your GPay, it's just like the UI is online, right? Say when you want to transfer 10,000 rupees from say my account to Mahendra's account, I'll swipe my card. It will say 10,000 transferred in say a couple of seconds. But finally, behind the scenes, what happens is after 2 days or so only the actual amount in cash should be transferred between the two banks. Say for example, mine is UCO Bank and Mahendra's is SBI means. After 3 days or something, in bulk, all the total amount of cash that was transferred to and fro, they might have a accounting book or something between these two banks, and they will swap the money, something like that. They will have some arrangements. So finally, for every rupee that you are spending via your debit card or GPay, you have an equivalent physical note present in a bank, right? When you open a bank, it's just not your just online rupees. It's like physical notes that you are giving it to the bank, and that is just reflected in your bank account passbook or in your debit cards or GPay. So everything has a physical, it's associated with a physical note. Whereas in the CBDCs, the there won't be a physical note at all. It will just be a digital ID that is minted by the government, by the RBI agency. That's it. So these digital coins issued by the government would be sort of the digital equivalent of your physical notes, and these are the truly online currencies. The only catch is now they will be controlled by the government. So in cryptocurrencies, you might uh, the, the the problem with Bitcoin and all these stuff. One second. The problem with Bitcoin and all these stuff is that the prices are volatile and all those stuff, right? So um, whereas in CBDC, since it's government controlled, you can easily sort of uh, regulate the prices. So it's same as your Indian rupee, it's not different. Uh, so in that case, the prices are regulated. You might not worry about some price fluctuation, all those stuff. And using CBDCs, they may get more control over the currency, and they might get more insights into how the currency is being used, and they might also easily able to track black money and all these stuff. I think so, yeah, because uh, physical note means you can have a machine or you can print the notes physically, something like that. Whereas in CBDCs, it's not like impossible, but it will be difficult. Right now, everything is digital, and they might have some mechanisms to figure out if someone else is forming new digital coins, something like that. And usually, it's like the blockchain network itself is controlled by the government itself, so no one else can't be entering that network unless they do some network attack or something like that. So it would be interesting to see how the CBDCs turn out really. That will be similar to your GPay, I guess. So that does that answer your question, Vagishwar?
Ah, yes, sir.
Okay, thank you. Okay, so in that case, the other question is, so can save transaction hash while sending someone Bitcoin or other. You can validate your transactions. Ashok, can you ask the question? Like I didn't understand it. You can save the transaction hash while sending
Sir, please explain a little bit about proof of one consensus
proof of work.
algorithm. Proof
Proof.
of burn.
Oh, burn. Okay. So
Ji.
proof of burn is in proof of work you have to spend some computational um, some computational power to show that you are honest and you're serious about the Bitcoin framework, the Bitcoin network, and to show that you are not malicious in anything, you have to spend some power, so that the other nodes will first of all look at your block and validate it and see whether to accept it or not. You should solve the puzzle. But this puzzle solving is sort of um, uh, so much of high computational power, and these might require physical resources also. Like, so proof of burn is somewhat similar, but now instead of burning your actual money, as in like to buy computational power systems or anything, what you can do is you can burn your bitcoins, as in you can send your bitcoins to unspendable output. So usually what you do is, when you create a transaction, you will have your input and then your output. The output will have the receiver's bitcoin address.
Okay, thank you, sir.
Right. So what you can do is to show that you have burned some Bitcoin. You should just mention your own UTXOs, whatever the miner is having, his own unspent Bitcoin, and the output should be empty. In that case, no one can point to this uh, the unspent coins, because if the output is empty, right, irrespective of any condition you provide or any private key, anything you provide, it won't satisfy this condition, empty condition. So it will always return false. It won't return a true anytime. So in that case, these outputs are called as unspendable outputs. So this is basically, you have burnt all the inputs. So this is a way to show that the proof of burn, and you get to instead of solving the puzzle, you burn some bitcoins and tell, hey, I have burned some 5 bitcoins. Take this block and try to add it to the blockchain. And as part of that thing, you will get a reward, say 2 bitcoins or something.
Okay, clear, sir. Thank you.
So, but doesn't make sense, right? I'm getting a reward less than what I'm burning. So, I mean, that has to be some this thing, some other rule applied. So I say I'm burning 5 bitcoins, and you give me a mining fee of 2 bitcoins, or I mean, currently whatever is the reward. I
Right.
mean,
So
it's six.
when I was telling also, it will sounded weird. Like it might be more also like uh, I don't know like a proper the number of coins or something, but the basic idea is they will get a profit, of course. Like if they don't get a profit, so by mistake I might have told 2 bitcoins. Maybe like they get 10 bitcoins in return as reward, something like that. So
Okay. No, because the as we know that the reward currently is at, I think, 6 or something, is that's fixed. So
yes.
then yeah, then they have to be burning less than that. So there is a limit on what they can burn. So how will that work in that case? What I'm trying to understand that, since the person who burns the maximum bitcoins,
Okay.
he becomes a miner in this case, proof of burn. But the reward itself is at a ceiling of say 6. So how will that? It's not, there is a fixed limit on the upper this thing. So
Yes, the thing is, I'm not sure about this reward, especially in proof of burn. Um, s- um, this proof of burn is not that much famous. Like it's not like very well known. It's just like I don't think there are practical like real world networks following this proof of burn. I have not heard of one. Uh,
Or it could be like an auction where when you decide how much profit you want to make. For example, if I'm getting just 6 bitcoins, so obviously if I it depends, the more the competition, probably the lesser could be the gain. I mean, I can maximum may go to 5. A person who is okay willing to exceed 5 may go for a lesser profit or something like that. That's why I'm not clear how does this work in practice.
right. Um, mm, there might be a limit. So these are all like sort of like research papers or white papers, um, like that. So uh, okay. So when I just googled and saw, so it's not like they just get one time opportunity to mine the blocks on burning. It's just like they can add a sequence of blocks once they burnt a new some bitcoins. So as in like if they so here in Bitcoin it's the case that if I what do I say, if I solve the puzzle once, it's the case that you just you can propose one new block, right?
Yeah.
Whereas in proof of burn, burning say 5 bitcoins will give you the right to propose 5 new blocks, 10 bitcoins, 10 new blocks, like that. So
Okay, I see. Okay.
yeah, so thanks for asking that down. Like you and I googled up and so these sort of like there are so many consensus algorithms like proof of burn, proof of stake, and all those stuff. It's just that it only like few of them have been deployed in the real world and really makes sense. So there is like proof of luck or something also that was published from IIT Madras, I guess. Like they have to play a game or something, and or something like that, and they have to once they solve the game or something, finish that game, they can get the right to play on the blockchain, add the block on that blockchain, like that. So there are so many consensus. There was one consensus where it just tells like proof of random or something like that. So basically uh, what they did is like Intel is having a there is like a processor feature in Intel called as Intel SGX. So this SGX is like a small you can take it as like a hardware module within a processor, and what basically this SGX does is it sort of guarantees that your laptop is trustworthy, something like that. As in, it's not attacker controlled, possibly, or that part of the hardware is trusted, and there is like a separate network where only SGX present hardware. So only the nodes having that specific processors, Intel processors, having this SGX feature can join the network. And how they will add blocks is there is a feature in SGX where it will generate a random number or something, and SGX is trusted. The attacker cannot control SGX, even if the laptop, even if the user is malicious, if the attacker is malicious, he cannot tamper with this SGX processor. And what will happen is that random number will be say like um, say like 0 to 100 or something, and in every round one node will be getting the maximum number, and that node will tell I got the maximum number, they'll somehow communicate among themselves, something like that, and they will propose a new block. And the proof of verification is along with this, they will send like a private key or something, like a digital signature. This SGX processor will emit, and the other processors will verify it automatically. So all this type of innovative things are all there in this proof of consensus work. But the limitation in this SGX is now you place a limit on the nodes joining, right? You cannot take your uh, some laptop and you cannot go. It will be the case that only uh, the laptops with SGX processor can join the network.
So sorry. So in this case, you're saying it's not competitive. It is allocated by the SGX who can mine the block. Is it?
Yes, so SGX is sort of trusted, so it will have like a random number generator. So the nodes, you might think, what if Intel is a bad guy and they rig SGX such that they be partial towards some miners. But the assumption is SGX is to be trusted. It will be fair and the random number will be truly random. No one can guess that number. So in that case, in a particular round, only that node with the maximum number or something like that, they will be able to propose new blocks.
Okay.
Okay. So Shriman has asked another question: can a miner customize the criteria for picking up transactions for inclusion as per their preference, or is it fixed across all the miners? No, it's not fixed across all the miners. A miner can say target your transaction specifically and blacklist your transaction, as in he will not, the miner will not take your transaction in a block at all. If say like I don't like you means I will not accept your transaction even if you are paying a huge fee. So there is no compulsion for a miner to accept all the transactions in the block. He can reject some transactions like that. The underlying fact is, if the miner is keep on rejecting transactions, is basically that is losing out on extra fees, that is the transaction fees on top of the mining rewards he might get. So the 6.25 Bitcoin rewards that the miner is getting is constant, but if he adds like 1,000 transactions and totally it is coming up to like half a Bitcoin, that is equivalent to like $10,000 or something like that, right? And the miner won't want to let it go to waste. So the miner's mentality, if it is for getting money on the investment that he has done for the uh, that he has done to buy all these computational power systems and everything, then he has to be money minded. So in that case, those transactions will get accepted in the blockchain, will be added to the blockchain by the miner. He'll be trying to maximize the number of transactions because transaction fees will be high. So that is a reason why there is a limit on the maximum size of that block, because what the miner can do is like to 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 gain maximum incentive, right? What is one way? He can add like 1 lakh transactions, or say like how many ever transactions he wants to add, he can add, and together they might try to solve a puzzle. So the puzzle solving is just like one time he wants to solve it, but in return he gets all this. Apart from the Bitcoin reward, he will get all these transaction fees, right? And this might sort of endanger the network, because all the nodes might not have that much network capacity to receive all these transactions at the same time. So that's why they place a limit on the block size to make it more scalable, because finally all the other nodes should also get in sync with their other nodes to sync up their longest chain and all those stuff, right? And the number of messages that are being sent will be huge. If the size is also huge, it might hamper the speed of the network and all those stuff. So for that, they place a size on the number of transactions or the size of the block transmitted. Does that answer your question, Shriman? Okay, cool. Um, Dr. Gautami Paruchuri, yes. She has asked a question in Bitcoin transactions, whether the length of the blockchain increases the value of the Bitcoin or it decreases. So when you tell it increases the value of Bitcoin, um, you might see value as in two things. One, um, the monetary value, and the other is the trust value. Right? Trust as in whether you can trust in buying bitcoins or not. The other is monetary. Say for example, uh, like an example is like there might be a situation where um one Ukrainian dollar is 100 Indian rupees, say today. But will you trust that and convert yours to Ukrainian dollars? And keep your money, like some people they might convert it to US dollars, assuming that US dollar is sort of like strong and it don't erodes completely like that. So both are sort of similar, but the thing is the trust and monetary, it's sort of similar only. Sorry, it's sort of similar, but the thing is, especially in Bitcoin, the monetary is always fluctuating. It won't be irrespective of the length of the chain or whether it's the longest chain, uh, whether the longest chain height increases or not. This monetary thing will be fluctuating. Even I'm not sure how, what are the reasons behind this fluctuating. It's basically like demand and supply issue, right? If many are buying bitcoins, uh, the price of bitcoins will rise. On seeing that everyone will stop buying bitcoins, then it will automatically come down. So all this is sort of the price is not fixed. That's a disadvantage of Bitcoin. But the trust that your bitcoins will be safe uh, will increase with the height of the chain. So what I mean by trust in this case is the the founders of Bitcoin. So like in nowadays, like for example, in advertisements or something, you might see invest in Bitcoin. You might see this term invest in Bitcoin. So something like gold investment, where you buy gold and just save it so that at a later point in time when you sell that gold bar or something, you will get an extra profit apart from the investment that you made. Similarly, if you buy two bitcoins for $10,000 or something, in future it might be $20,000 and you might get a profit of 10,000. So that's how they advertise these things in current day scenario. So something like a temporary investment where in the future you will get back your dollars with some profit. But the founders of Bitcoin aimed for a world where there is no individual currency like a national currency. The only currency in the world would be Bitcoin, right? So your coffee, tea, any commodities you buy, it will purely be in Bitcoin itself. There won't be any other currency. So in that future world of uh, theirs, Bitcoin won't be as in this investment case, right? You won't be converting to Bitcoin to another currency and then using it in the real world. So in current world, like if you have like 10 Bitcoins in India, you cannot go and buy a laptop or something from a store. You should convert it to Indian rupee and then only buy. But in a future world where the only currency is Bitcoin, you might have the option to directly buy in Bitcoin itself. pay 1 Bitcoin and get a new laptop. So in that case, the monetary value would be fixed for Bitcoin, since that's the only currency there. Only is that the value, the commodity value would be changing. That's the value of the commodity, but the monetary value of Bitcoin would be fixed. And in that case, the chain of the Bitcoin will determine the security of the Bitcoin, as in whether your transactions are confirmed or not, all those things. The trust in Bitcoin, whether to trust this cryptocurrency or not, that will enormously increase with the increase in the longest chain length. So does this answer your question, Dr. Gautami?
Yeah. Yeah. Thank you, sir.
Yeah, thank you. So any other questions anyone has? Okay, so if not, then we can wrap up this session. Uh, there are no other questions. Okay, thank you everyone for attending the session. Yeah, thank you for making it interactive. Thanks Mahendra, thanks Abhijit. Yeah, thanks Shriman, thank you all. Yes, Komal, you have raised a hand. You have any question? Komal, do you have any question? Thanks, Juma Datta. Thank you. Okay, sure. In that case, yeah, thanks, Dr. Gautami. Thank you. So let's wrap up the session. See you all next week, Saturday, same timing, 6 to 8 p.m. Thank you all.